Welcome to BizCubed's webinar series. Today we'll be discussing lookup and joins in Pentaho Data Integration. We will review the 5 following lookups and joins, that being database lookups, screen lookups, and merge joins and merge sort. And we'll also be looking at a web lookup. We'll begin by having a look at this really complex ETL job that I've got set up here, which actually initiates all but one of the lookups that we're going to be looking at today, which is the web lookup. But as you can see, this one does a database lookup, does a merge sort, does a merge join, does a stream lookup, and the merge join. Now, in my environment, just for those who would wish to know, I'm using Pentaho Data Integration Client 4.3 GA on my Ubuntu 12.04 LTS notebook and MySQL 5 as the backend database. I've also got database logging enabled to a Postgres server. There's no reason why I've got 2 different database servers running. It's just the way that because I have it set up that way for other clients. Okay, let's start off with having a look at the database lookup demo. Now, this is a very simple example. So basically what we've got here is we're doing a table lookup step. So we just go in here into inputs and find table input, drag that across, and we would open it up and come in here and select the SQL statement that we would like to enter. Now these are very, very simple. The data is actually from the Pentaho sample data, and we've just modified or just imported it into MySQL. Now, to get this SQL statement, I've just used the standard Pentaho functionality of clicking on Get SQL Statement, selecting the table that I want, and just double-clicking on that. It comes up with, do you want to include the fields? It's always a good idea to include the fields, and hit OK. If we just hit a preview on that, you'll see the rows that it supplies back. Not for any particular reason, but I've enabled a lazy conversion. Lazy conversion means that the database step will, the PDI will not change or do conversions for the actual row into a Java type until it actually has to. Make some of the processing quicker, and I didn't want other steps hanging up the speed of the actual lookup step, because that's where we want to notice the speed differences. The next part that we've got here is the actual lookup step. Now you've got a lot of actual lookup steps here. I've only picked out a few of them because a lot of them are reasonably self-explanatory, like the check if file exists or check if column exists, check if web service exists. They're all fairly basic. So what we've done here is we've used the database lookup, just simply dragged it in. Now in the database lookup, again, you just pick in the connection that you want and the table that you want to get it from. So previously we had order details, and now we've got orders. So we're basically going to create just a flat record with all the order information, including the order header and the order detailed line. The little dummy step here is simply because I have been playing around with getting the best performance out of this ETL, and going straight to a text file is slower than using the fast dump text file, which is also slightly slower than using serialized file output. the text dump fast, which is what I'm using here. The reason why it's fast is it doesn't do any data conversion, so it makes it a very fast output step, whereas the normal text file actually will look at the field format and ensure that the data is formatted to that. So if we go and run this step, just hit play and launch. Now, as you can see, that lookup step isn't overly fast. The reason being is none of the features and functionality within Pentaho has been turned on to enhance the speed of that lookup step. Once this is actually finished, we'll actually go and have a look at some of the other advanced features within inside the database lookup step. So that's all finished. Now what we can see is it took 19 seconds to run the job, and the slow step, of course, was the database lookup. So, and we can also see that if we have a look at the performance metrics, which I've got enabled on this job, so that you can see here that the database lookup ramps up as the data starts to come in, and then stays rather static for the rest of the processing. Now what we can do is there's several options for speeding up this process. The important one to start off with is enabling cache. Now, enabling cache allows you to load individual rows, or sorry, when a row is loaded, it will be loaded into memory, and a certain number of rows will be kept in memory until, and when that number is met, then it will start emptying out the first or the earliest rows that were brought into it. So a standard first in, first out sort of mechanism. The cache size here, we've currently got it set to 0, which means it will cache everything. So we're just going to hit OK there, and we'll run this again, and we'll see the difference in performance. So we'll run it. So as you can see, that took a lot less time. So we're down to about 3 seconds to run. Now I think I can actually make this run just a little bit faster if I come in here and say load all data from the table. So this actually pre-populates the cache with all the data from the rows. Now for such a small data set, that's quite good. It will give us really good improvement in performance, but you have to be very careful on the amount of data that's coming in, because it's going to quickly use up your Java stack space and could cause your ETL job to fail. All right, we'll go and run that and see if I've got a little bit more performance gain here. Well, that was certainly quicker, and as you can see, it's less than a second now that it actually took to run. So enabling, so out of the box, if you don't enable cache, it's going to be slow, because each and every time it will go back to the database and do a select values from the table. Then if you enable cache, it will look up for each new record that comes in, and this being a order lines versus order numbers. There is approximately 4 or 5 order lines per order, so that did significantly improve the process. And then when we told it to load all data, I think there's only about 100 odd records inside that table, so the performance was excellent. And the performance there is as good as the stream lookup, which I'll show you next. All right, stream lookups. So stream lookup is really useful if you're pulling data in from just separate data sources. It's also very fast and because it loads all records from the lookup step into memory prior to running. So in this example, we're actually running the exact same process. So we're getting our order details in, then we're getting our orders in, we're merging them together using a stream lookup, and then again using the dummy record and serializing out to a file. Now, the table input step, as you can see, it's again just a normal table input, selecting the fields that we want from the database. And again, I've turned on lazy conversion. By default, that's turned off, and it's recommended to be left off until you've got something in a production environment where you know that it's stable. Now, in the lookup, you have to define which step is your lookup step. So in this example, it's going to be my input orders table. Now, the important thing to notice here is the step that's driving is the order line, so the one with the most records, and then we're using the orders as the what's being looked up. So we're looking up order number from both fields, and we're getting in the values that we want. Now again, this was quite simple, so I'm just going to come in here and delete these. All I've done is I've just gone in and done get fields. It's automatically populated the fields. Because order number is coming in from the order line details, I just come in here and delete that so that I don't end up with 2 copies of the row. Now, I'll just turn that on because by default we do the preserved memory is turned on, and we'll just do a test of it with both it turned on and turned off. Okay, so launching that, and lo and behold, we have an error. So we'll just go quickly. Zero rows, byte array. We'll just open that up again. Okay. Wonders of a live demonstration. Okay, so as you can see, that has been very fast, and it's approximately the same speed as what your database lookup was with cache turned on and all rows pre-populated, which is what I would expect. And that's because this is effectively what the database lookup with caching and all rows fetched is actually doing. Now, if we turn that on and run it, it's a little bit slower because what it's doing is it's utilizing less memory and more CPU to actually do the same processing. So it's only added a little bit on here, but if you've got large data streams, that is certainly one way of handling the processing. Okay, let's go and have a look at the next lookup step, which is the web lookup step. So this one is not as simple as the other examples. So what we're going to do here sounds simple, which is go and get all our customer details and find their geo coordinates based on their address information that's coming through. So if we just go and have a quick look in the customer data, as you can see, we've got address line, state, postcodes, etc. in here. So we can go across and have a look at that. Now, the other interesting thing is we've got some special characters in here. Now, those special characters are going to cause errors in later steps. So what we've done is we've got a catch on error here that's just going to ignore those cases. Typically, we'd do some sort of parsing to remove those special characters. There is some JavaScript in here. So this JavaScript is simply a very convenient way of putting a string together. So we've got our Google Maps API address, and what we're going to do is we're going to concatenate the address, city, country, and postcode in after that address with commas between it, and then we're going to put this sensor equals false as an end parameter, which is required by Google. We're going to go through and we're going to replace any spaces, which is hard to see here, but this is actually a space, with %20. So that's a very standard way of presenting spaces in a URL. If we don't do that, again, the HTML request will fail. So we're using the HTTP web service here, which is one of our lookup steps. Now this step is going to take in our URL from the URL that we built in the previous step called GeoURL. It's assuming that it's standard encoding, and it's going to put the results on the in this field here. And that result from this will be an XML file. Now there's no fields or parameters that we've set in here. We could have put some of the parameters in here, but it was easier thing we were already using the JavaScript to just leave it all in the one spot. The next step, as I said, we've just got that error handling for the special characters that are coming through. The next step is an XML step, which will actually parse the XML statement from the results column, and it will look for inside of the results this geo-response results geometry location path, and from there we'll be getting the latitude and longitude nodes. And then we're simply going to output it out to a text file, just a standard CSV file with longitude and latitude on it. So what I'm going to do is we'll just do a preview here so you can have a look at what information is actually coming into this process. Now, of course, being a web lookup, this is actually a fairly slow process because you've got the latency of the internet over each step. Some of these web services actually allow you to bundle up a block of records to be encoded and then return the result set from that, that bundle, which of course is a lot quicker. Now, what we can see over here is this is the XML document that's being produced by Google. Now, within this, we've got our Google code response. Down here a little bit more, we've got geometry. Whoops. Sorry about that. We had our geometry, and then inside geometry we had the longitude and latitude. I'll just close that down. All right, so if I run that to fruition, and that's just simply going to output the CSV file. Now, as I said, we could do some sort of bulk loading. If we were not going down to individual addresses, there might be a possibility of caching this information. So getting doing a select from the customer table where we're only giving country and state and maybe city as a distinct set, and then passing that to a stream lookup, passing that to the HTML lookup, and then passing the result of that to a stream lookup so that we can speed up the actual individual records. So if we've got 100,000 customer records and we only ship to the 6 states in Australia, you're only really going to be finding 6 actual individual records. So that's outputted to a file, and that file is just this geocoding file. And all we've done is we've put these longitudes and latitudes in for each city. So a very simple and straightforward exercise there. Okay, next step that we're going to have a look at is going to be a merge join. Now, merge joins are another way of joining the 2 subsets rather than using lookups. It can be extremely fast, especially when you're looking at very large record sets that have low cardinality, that being that they've high cardinality, that being that they've got lots of distinct records in there that are common between the 2. So the most important thing to note with using any of the join steps is they need to be sorted prior to being used. Otherwise, you're going to get varying results. So in here, again, I've got my order details coming in, and you'll note that unlike the other steps, I've got the order by statement there. And here's my orders, and again, I've got my order number being the sort step for here. Within the merge join, I'm doing a simple inner join. You have got the options to do left outer, right outer, or full outer. The full outer join is equivalent to doing a, I was going to say a contingent cross product, but it's not. Full outer join just means that if any records exist in one and doesn't exist in the other, you'll still get a row, and vice versa. Okay, so I'm matching here on order numbers, and of course you can use the get fields, which will allow you to pre-populate the fields so you don't have to type them in or pick them up from the selection boxes. And again, we're just outputting them off 2 files. So we'll just hit play on there. Now in this particular step, the slowest point was actually writing to file because I've actually got it set on the not the fast file output, and that was running at 1.7 seconds, and it's that text file that's caused the slowdown. So we'll just save that again and rerun it, and we should find that that's at least as fast as what we've noticed previously with the caching examples. So 1 second, so the other ones were about 1.7, 1.8, sorry, 0.7, 0.8. Okay, so this one doesn't use as much memory, but the pre-sort can either put loads on your actual ETL process or on your database to actually sort the records before coming in. The next one to have a look at is the merge sort demo. Now, the reason why I wanted to particularly show the merge sort is it's closely related to a lot of these other merges that we actually need to do when we need to sort records prior to actually loading them. So in this example, what we're doing is we're loading in a CSV file. I've done a row sort, but I've changed the number of steps to, or copies to start to 4. Now, what that will do is from the CSV file, it will distribute the rows to 4 copies of the sort rows function. So it will actually generate a parallel sorting mechanism. Then what happens is the result from that will then go into the merge sort, which is simply allows for the rows to come in and be sorted very quickly inside the system, because it's effectively just dropping new rows in a pre-sorted stream. And then again, we're going to output them off to our table. So this is a reasonably quick little process. Now, the interesting thing that you'll note is that the sorts are blocking steps. So we need to wait for this sort, even though it's in parallel. We've got to wait for that sort to finish before that sort can start. So sorting can be a pain inside your ETL where everything else is running in parallel except for your sorts, which is stopping the flow of data within inside the system. So that's sorted 283,000 rows pretty quickly. So that's that example. And then finally we'll go back and have a look at my big consolidated one. So this basically does all the things together. So we're basically taking in our orders, we're taking in our order descriptions, we're merging on customer details, doing a merge join to get customer order details, and then outputting it to a file. And we'll just check to ensure that we've got all the nice caching enabled, which we do. Preserve CPU turned off. So this is actually bigger than what the other ones were before because we're doing a lot more steps in here, but it should still be relatively fast. I believe we're finished. So as you can see, we've put out those 23,000 records very fast, and the record size is a lot bigger now. So we've got customer details as well as product details coming in for each order and order details line. So that concludes today's webinar on lookup and joins in PDI, and thank you for attending.